Today we're going to look at some strategies for working with trigonometric identities. So the first strategy that we're going to use today is changing everything to be in terms of sine and cosine. So here's our example. We have cosecant theta times tangent theta is equal to secant theta. We always pick what looks like the more complicated side. In this situation, cosecant theta times tangent theta, just because there's 2 versus 1. So I'm going to go to my formula sheet, my reference sheet, and cosecant theta, we can see on our sheet, is equivalent to 1 over sine theta. So all I'm doing here is, use theta, not x, all I'm doing here is making a substitution. Okay, then I'm multiplying that by tangent theta. Now tangent theta has 2 identities on our sheet. Tangent theta is equal to 1 over cotangent, and it's also equal to sine over cosine. It's most often more useful to use the ratio identity, and that's because we're going with that strategy of changing everything into sine and cosine. So if we change it to 1 over cotangent, we're not really simplifying anything or kind of making anything happen. But if we change it to sine over cosine, you'll see in a moment that now we have this sine over sine here. So again, it's usually more useful to use the ratio identity for tangent. Sometimes we get kind of into using the reciprocals and we forget about the ratios. I would say that your gut instinct when you see tangent would be to use this one. So finishing up this problem, so we're trying to see, is that equivalent to secant theta? All right, and hopefully you've noticed by now when you multiply fractions, we know that we go straight across. 1 times sine is sine theta. Sine theta times cosine theta is sine theta times cosine theta. We're still wondering if that's equivalent to secant theta. Now what we have is sine over sine, which makes a giant 1. And what's left is cosine theta in the denominator. So that's important. We can't just move it up to the numerator. It's in the denominator. We keep 1 in the numerator. Still wondering if that's equivalent to secant theta. Let's just check here. If we go over to secant theta, we can see that it is equivalent to 1 over cosine theta. So we can replace now, we can go back to what we started with. Secant theta is equivalent to secant theta. We did it. So once again, that strategy was that I took my original problem and I used the identities that would make everything be in terms of sine and cosine.